Okay, hello. Speed of sound of gravity with Otangelo. We're going to have a conversation, hopefully, about the meta problem of
Speed of
science.
sound of
And
gravity with
here it
Otangelo.
goes. Wish I'd let you mute the sound when you're waiting for a video. It would be much more convenient. So, anyway, let's see. I watched a video this morning, and you had this. Well, I don't know. You want to say anything?
Yeah,
You
I
got
made
it?
it basically yesterday when I saw your screen about your attempt of explaining DNA. So I said, well, let me make a video of how I understand the issue here, and then we can discuss it. I made one very similar. It's actually the watchmaker argument. It's at my Intelligent Design Agents Academy YouTube
Yep.
channel, and it makes a very similar argument. I think I have brought in some other explanations in this one, but it addresses basically the same problems.
Okay. Okay, so what I was talking about is information on that billiard ball example, and it's basically about you have a system, that's basically a black box, okay, and you have some sort of input, going that way, and then you have some sort of output distribution, that sort of thing. So you have an input and you have an output, okay,
Mhm.
and then but this is okay. Inside the black box, of course, there are other billiard balls that we can't see. And these are going to affect this output distribution here, right? So it's going to
Mhm.
affect that part, right?
Mhm.
So that's the point. And then every time you strike that thing with a billiard ball, it resets itself so that if you strike it in exactly the same way again, you will get exactly the same distribution over here, right?
Mhm.
So this is called an information-driven system, and that does not necessarily have to have any intelligence associated with it at all. I mean,
Okay.
these could be rocks, and this could be a rock over here, and they could have just fell that way. And of course, living systems are quite a bit different because rocks can't reset themselves to the same pattern over and over again, whereas living systems can. So this would be like the DNA, because the DNA is usually going to prescribe the same output almost every time. Okay.
Yeah, through DNA replication. Yes.
Yeah. So that's the point. The DNA would be the information. So the question becomes, so you understand that information does not have to have an intelligent author and an intelligent recipient.
But it depends in what context that we are talking about information. If we are talking about descriptive information, let's say that we see an event happen and then we describe the event, that would be descriptive information in regards of the event and describe it. But we are talking in biological information in regards of information, which the flow goes from the information stored in DNA to transcription, messenger RNA, and then translation in the ribosome. So it is kind of a different kind of information. And I don't know, I describe it actually as as prescriptive information because the information has to be there in the DNA in order for the information flow to occur. So where would you put that example which you just gave now in this context? Where would that be?
Okay. If you got a human being over here reading the output, reading the input, or the middle, and reading the input, right? Then
Mm-hmm.
this would be called descriptive. The human being would describe what is going on.
Yes, correct.
So this is descriptive, right?
Mm-hmm.
But you
Yes,
see, we've added this little guy here. Okay.
yes, yes,
Uh,
correct.
we're just talking about a bunch of rocks that fell together, and there's some sort of a weird system in nature, you know, where energy resets these rocks every time, and we come upon this phenomena where we have the input and the output, and then we describe it. Okay.
Correct. Yes.
And okay, so suppose this human likes the way, so he really enjoys the way these rocks fell. So he says, that is prescriptive because I liked the way the rocks fell. So you see what you.
I wouldn't say that it becomes prescriptive, because at the beginning of the event there is no prescriber, or there is no information input which prescribes how the event has to occur.
Okay, so there's no. So your complaint is that there isn't another human over here basically throwing the rock.
Well, if you simply throw the rock, then you are not informing the pattern of the rock. You are just throw it, and then the pattern can be chaotic or stochastic or whatever. It can be any outcome. But
No, no. If you threw the rock exactly the same way every time, you would get exactly the same output.
Okay.
So if I say to you, bear, okay, I'm over here and I say bear, you always know what bear is. You always think big furry thing that might eat you. Okay. So basically what I'm saying here is that there is no requirement for this guy or this guy or any of this stuff. Okay. We come along with science and we say, oh, it's descriptive and it's prescriptive, but that is sort of our human judgment of it. Okay.
No, I think I made a clear distinction between what would be descriptive information, which is just the description of an event that happened, and prescriptive information, which would be an agency which prescribes how an event has to occur.
Okay, so where does descriptive come in? How do we have descriptive without a human being to describe it?
Well, if you don't have anyone to describe it, then the event can simply occur, but there is no one to observe it and to describe what happened. Simply
Okay,
that.
Yeah. So we have no description. We have no descriptive information.
Correct.
Okay.
Yes.
Okay. And then you're saying that this was prescribed, but I'm saying no. These rocks just happen to fall together. This is a perfectly natural system. Like if you imagine a river winding its way through a bunch of sediment, nobody prescribed that, even though the river does arrive at the location every time. Okay.
Mm-hmm. Yes.
Okay. So that's a purely physical information system. Okay.
Well, it's I wouldn't say it is an information system, especially if the flow of the river is not organized through prescriptive information. It's just the flow of water going down the river.
What do you mean by just?
Well, there is no agent which directs a precise flow of the river. Now, we can make another example. Let's suppose that the water supply in ancient Rome, they had a very elaborate water supply which came from the mountains at a very distant, from very distant places. So they had to engineer that system in order to the water supply be possible in ancient Rome. So there was an engineering process which prescribed how that water flow had to occur.
Right. Okay, you see the problem here. Romans. Okay, you're talking about a system where there are Romans, humans like you. Okay, so you're thinking, you're thinking about this kind of river. I'm telling you about this kind of river, which still has information. In this kind of river, okay, the water's going to flow straight, and then it's going to make a sharp turn, go down. It's going to make another turn, right? So
my point is that the water flow was directed for a specific purpose to supply water to ancient Rome. So the whole water supply was an engineered process by Romans.
Right.
In the above case, there was no agency at the beginning to direct the water flow. It just flows naturally upon the natural circumstances.
Yep. And Rome is down here, so the water's not getting there. Okay. But you see, you're automatically assuming these humans down here, these Romans, right? So they're Roman engineers. You're automatically thinking Roman engineers because you are an engineer and you can't seem to get that out of your head. Well, I'm telling you that this river up here has much more information because it goes here and there's a little bend and then it goes here and then there's like a long curve and then it goes here and then here and then around there.
Yes,
There's
but what
much.
kind of information is it? You see what happens and you describe what happens, and what you are describing, the event of describing what you see, that is providing information. It is descriptive information, but at the beginning there was no
Right.
agency which directly engineered the flow of that pattern of water. It's just a natural occurrence.
Right. So it's physical information, and then we have descriptive information where we describe it. And then we have a prescription over
I
here.
don't know what you mean by what did you say? Physical information. What do you mean by that?
Physical information is the way things are arranged physically. Okay. There are, like the way the billiard balls are arranged physically is physical information.
Okay, but was there an agency which prescribed how that flow had to occur?
No, there was no
Okay,
agency. There are
okay,
no agents.
okay.
This just fell together.
So a natural pattern of water flow from a river downhill, that there is no agency at the beginning. There is just a fountain which springs from the grounds of the earth, and then it flows naturally down the river, and we can describe what we see, and that would be descriptive information. Is that correct?
Right. Right.
Okay. So, and as I said before, now if you want to have a water supply system in ancient Rome, then you need to think about how you're going to do that. And of course, then there are these bridges which have to be built, and you have to calculate the level from a higher point to a lower point, and so forth. And this was a very, very elaborate engineering system which had to be elaborated by ancient engineers. And so there was actually an information input to construct that water supply system. And if there would be, and when we go to ancient places in Rome and we see an aqueduct, then we immediately know there was an intelligent agent back then, 2,000 years ago, which made that system using its intelligence to perform that action with an outcome which was desired with a purpose. So we have two distinct systems. One which is natural by natural springs which flow the hill up down, and the other is an engineered system. So we have here actually a nice contrast, Mike.
Nice contrast. Yes, I agree. There's hang on a second. I'm trying to find. Oh my God, Rotor Estate Brew. I end up with wine when I try to type in Rotor information. I'm not going to be able to find the book. There's a book called I've got it on my table here. Information and Its Role in Nature, and he talks about purely prescriptive or purely physical information, and he explains it using this billiard ball model. And let me try to share that again. Oh, where the hell? Oh my God. Oh, let's see. Okay. some reason it only gets the windows that I have visible, and I have to move them. Okay, so here's the difference in these things, right? You are automatically assuming God. And
No,
you are
here we are talking just about natural river, which
right.
doesn't require an agency at the beginning. There is just the spring where the water comes out from the fountains of the earth and then goes downhill to its places to the seas.
Okay.
And the second, yeah.
And suppose we come upon a village in Rome where they have water, and so they have their pragmatic. Hang on a second here. I'm going to get another marker. They have their pragmatic information right here. They're getting their water, so that's the pragmatic part. That is the prescriptive pragmatic. Okay, so that is the function. They have water, and there's a source of the water over here, and we come upon this village and we say, oh my God, this looks like it is designed because it goes straight and then it goes down and then it goes over, right?
Yes, there are patterns of design which we do not see by a natural river.
But then we get a really smart geologist, and he comes over here and he says, oh no, wait, these don't exist. Okay, we found out that there is a bedding change in the rock that made this impossible, or basically there's a barrier right here, and it made that go straight down that hill, and then there's another bedding change right here that made this go straight over. And so these guys are saying, there must have been a designer for this to happen so accurately. And the geologist says, nope, not a designer. We found out that there's a reason why that's at right angles. Okay.
Well, that is a possibility, Mike. I agree with you on that. There can eventually be structures or patterns in nature which appear to be designed, but in reality are just a natural pattern, a natural occurrence. That, of course, can occur. But I brought up the example of the aqueduct in Rome, and they built bridges specifically with the purpose to supply water to ancient Rome. And nobody in its sane mind, seeing that structure, would say, well, that is a natural occurrence, because that simply doesn't happen.
Well, these guys are saying, okay, nobody, they're calling the geologist insane. They're saying, you're crazy. There's no way that river could have been in such precise lines like this. You're crazy. That could not have happened physically.
No, Mike. If the evidence is there that it is a natural occurrence, then why should we not admit it? We admit it as much as you guys do. There is no problem with that. But there are things that are indeed just made by intelligent agents, like the aqueduct delivering water to ancient Rome.
Yes, and because these people over here, all these little Romans over here, they're all intelligent agents, and they're saying no fucking way. This has got to be designed. This has got to be designed, and they don't believe the geologists. They're saying, you geologists, you just want to sin. You don't want to believe that this aqueduct was designed by these Romans.
This is not the matter now, Mike. The fact is, and I think we both agree on that the aqueduct which was supplying water to ancient Rome was the product of engineers which had to make the calculations. Since the water came from a very long distance, the level of decleaving was very, very small, but it was sufficient for the flow of the water to get to Rome. And it has all the signs of engineering, and the bridges which were built to deliver the water to Rome that is by no means. If someone would claim that construct was made by random events, by environmental factors, they would say, well, you are insane. That's simply not possible. And that is a reasonable inference to make when you see certain things that are clearly made by intelligence, which natural occurrences could not provide.
Okay. Now, these humans here that are saying, okay, the geologist not in the picture yet, right? So these humans here look at this and they say it is a reasonable thing. Okay, we're not talking about ancient Rome, Otangelo. We're talking about my diagram here. Okay, they would say, oh, it's reasonable. It's insane to assume that this was not done by intelligent design because the lines are so, I mean, it is so perfect. Okay, so then the geologist comes along and he said, oh no, I have found evidence. I have shown you how exactly this happened, right? And then
Well,
they
I would
say,
agree. I
oh,
would agree, Mike. If a
so you,
geologist can demonstrate by rational inferences that a certain pattern seen in nature is not a construct from intelligence but was naturally occurring, then why should we not agree? I would agree, of course. Why not?
okay, are you a molecular, oh my goodness, what did I do? Are you a molecular biologist?
No.
Okay. Okay, so molecular biologists find the evidence that you are looking for, and you don't know what that evidence is because let me ask you this. Can you tell me the structure of isopropyl alcohol right now? Could you write it on my board?
No.
Okay. There it is. Isopropyl alcohol. Okay.
Okay.
So I know this. Okay. And I know a lot of other things about this. And a lot of these things contribute to that evidence. And you guys are saying, no, no, no. We don't know geology. We don't know any of this stuff. So you guys are crazy. What did I just do? Okay, so that's where we're at, Otangelo. That is where we are at.
Well, I actually like to see actually into the evidence and then discuss it. And you
Right.
watched my video, correct?
Okay, suppose the field of geology is only 100 years old at this point. Okay, so it's 100 years old. Oh, that isn't very bright, is it? That's not very good. So we've only had 100 years of geology, and this guy, he knows pretty much of the story, but he doesn't know exactly how that right angle happened. He doesn't understand. He doesn't understand Bernoulli equations and things like that cause water to form the way it did. So he doesn't know the whole story. And these guys are saying, "Oh no, you have to tell me the entire story before I'm going to believe you."
Well, in regards of geology, Mike, I have very little understanding, so I prefer to leave it to the specialists and to those that understand their business.
So
I don't. So
why
I
don't
do.
you why don't
I
you
do
do
not.
that with DNA?
You have never seen me giving any opinion in regards of geology because I have not studied the topic. It could be even not me not being a geologist. I could actually, if that would be a field of interest of mine, the information is ready at hand through the internet, through books, through geology science papers. I could inform myself and then eventually give you an informed opinion in regards of geological events. But since that is not my field, so I prefer to not give any opinion in regards of these kind of topics.
Yeah, but you're giving opinions all over the place about molecular biology, and that's not your field. This one right here, by the way,
Well,
is one.
well, just let me stop you here. It
Okay,
is not my field in regards as a professional scientist, in regards of having a formal education. But as I just said you before, my molecular biology is something that I actually study for about 5 years now. And I have many science papers which I have on my PC. I have downloaded them and I use them as a base of my inferences. I study those. I have also many books in regards of molecular biology, and that is a field, even if I'm not having a formal education, is something that I am investigating, and it is a field which is of my interest.
Okay, so do you know what this one is here? The one I'm putting it?
It's oxygen and hydrogen.
Okay, this is the alcohol that gets you drunk.
And
This
you
is
have
the
two carbons, correct?
that's ethanol. This is the alcohol that makes you go blind. This is methanol. This is what they tried to put in our hand sanitizer recently. Okay, and this one is butanol. Okay, but you know molecular biology, but you don't know this stuff.
Yeah, I
And
don't know many things because, as I told you, I am not. I have no formal education, so there are many things that I don't know, and I have no problems to admit it. You know.
yeah, there's the thing is that you can learn a lot about molecular biology because you learn about these structures. These complicated things. They go like that. And then we have, do you mind if Immutable Destiny comes in and talks to you?
Sure, you can come in, no problem.
Okay, Immutable, did you want to come in? Was that? Let me know in chat because I'm not really paying attention here. Let's see. Okay. So anyway, so you know this part, and that's good. This part is, I mean, there's a lot you can learn about molecular biology without, actually knowing chemistry. But what you can't learn about molecular biology without knowing chemistry is how abiogenesis can happen and how these things can form. Okay.
Well,
How these proteins work.
right now you're making an assertion, Mike, which you make a positive claim, but scientists which work in the field, they do not make that claim because they do not know. And I think I have shared
Oh, wait a minute. No.
much.
What scientist says he doesn't believe in evolution? James Tour?
No, no, no. We are talking about abiogenesis. That's what you just mentioned right now.
Okay.
And abiogenesis has not been demonstrated
Well,
to be possible.
this right here is evolution, not abiogenesis. Okay.
Yeah, but you talked about abiogenesis. What do you want to talk about? Because my entire video, which was the reason that you started this stream, was to talk about my video. And my video, I am not talking about evolution. I am talking about abiogenesis and the origin of the genetic code. That is the main topic there.
Hang on a second. I'm going to invite Immutable. Oh, it's going to take me a second here. Okay, you were not talking about abiogenesis in that video. You were talking about evolution. You were talking about modern evolution of genes with a eukaryotic organism. All the stuff you mentioned in that video was all complicated cells that are 4 billion years away from abiogenesis. So I don't quite understand how you claim you're talking about abiogenesis.
Claim, Mike, that the first life forms were not complicated?
Yes, that's what I'm claiming.
Do you have
how could they be complicated?
do you have a scientist which would claim that the last universal common ancestor was not complicated?
The last universal common ancestor?
Yes, that is the one mentioned as upon which supposedly all the follow life forms diversified, and the three domains of life then emerged somehow. So that is basically claimed to be the bridge or the point from non-life to life.
Okay, here's Luca, and what Luca actually is a population of a whole bunch of eukaryotic cells, probably.
No, nobody claims that they were eukaryotic. The origin of eukaryotic cells is a mystery. And bacteria and prokaryotes are far simpler than eukaryotic cells.
Okay, but to get eukaryotic cells, okay, to get eukaryotes, we need 2 or 3 different prokaryotes. So that's not common ancestor.
Who makes that claim, Mike?
It started with Margulis in very early on with endosymbiosis, and we have a lot of evidence for that.
Yeah, but you are not at the first life form yet. We have to talk about.
Yeah, but that's not what you were talking about in your video. You were showing a complicated transmission, which I picked. So you're all over the place again. You're going back and forth and back and forth.
Let me stop you just a moment, please. You maybe didn't grasp what the analogy was or the intent of the analogy was, and I can quickly explain it to you if you like, okay?
Okay.
A car needs many essential parts, and one of those parts is the gear.
Okay. I have rebuilt automatic transmissions. I understand what you're going. You don't have to do the whole analogy for me. We got to go back to this. Okay, we have Luca, which is a eukaryotic cell. Okay, and then we have all these prokaryotic cells. No. I know. Hang on. I'm going to help you out here, Otangelo. I'm going to help you out. Okay. So now back here, you're claiming that there were simple cells, basically simpler. They're prokaryotic.
No. I don't claim that any kind of living cell is simple, and I don't know of any science paper which would claim that the last universal common ancestor or any life form is simple.
Okay, simpler.
Okay.
Prokaryotes are simpler than eukaryotes. We know this.
Simpler. Correct, yes.
Okay, we know that, right? Okay.
But they are still extremely complex.
Now you want to go back. Okay, we have our first eukaryotic cell right here, and then we have a bunch of prokaryotes contributing to that. So we have simpler cells.
Well, that's what you claim. I don't agree with that proposition, Mike. But anyway.
Yeah, because you don't agree with the science, because you don't know the science.
No. That's not science. What they claim are hypotheses which are not confirmed. The transition from prokaryotes to eukaryotes is not a proven scientific fact. It is just claims that are being made. There are hypotheses.
I really don't know why we're talking about proofs in the context of science.
Mathematical proof.
Science does.
Right.
Yes, correct. So, I mean, these are hypotheses which are unconfirmed, and there is much evidence.
No, there's actually quite a bit of
claim, and there are even papers which say that prokaryotes and the origin of eukaryotes is a completely different topic, and they are unrelated. And I agree with that assertion. You cannot transform a prokaryotic cell, even with the endobiotic proposal, into a eukaryotic cell. I mean, if you take the smallest free living bacteria, it has 1.3 million nucleotides, and
the smallest bacteria have smaller genomes than that.
Well, but they are not free living. You can take Mycoplasma; it has about 500,000 nucleotides, but it is a pathogen. It hosts in the human organism, and the amino acids, they are imported from the outside. Now, if you want a free-living bacteria which synthesizes all the life-essential amino acids, then they have about 1.3 million nucleotides. So that is very complex. It's not simple at all.
So, are you trying to imply that the size of a genome is directly correlated with its complexity?
No, there are many other factors, but I think the genome is very relevant.
So why are you saying? Okay, but why is that an argument you're bringing up then? Like, why are we talking about the size relative to?
Well, it is something that has to be explained, because a smaller of a living bacteria is not known, so the origin of that size of the genome has to be explained.
Well, there's prokaryotes that only operate using about 6,000 or so genes, and they might have 1.3 million or so nucleotides as part of that. The length really isn't what's used.
I have much tried to find the smallest free living organism, and what I have come up with is Pelagibacter rubic. It has 1.3 million nucleotides and about 1,300 proteins. Now, if you want to show me a smaller one, I'm very interested to know it. Now, if you say it doesn't synthesize all the amino acids, then it is a pathogen and it doesn't serve as a model to say, well, that is probably the smallest organism that can self-replicate and be alive.
Well, my
So
point though is that it doesn't.
and we can work from that.
My point though is that it can be 500,000, it can be 500 million, which would be of consideration is.
It could be just one protein with 400 amino acids immutable. That would still make my point, but go ahead.
Not really. I mean, you can have a lot of the genome that just does nothing, for lack of a better
Yes, but you have a genome which actually which codes for proteins which are life essential, and that are the ones that we are talking about. I mean, there is a minimal proteome which is life essential, and I would say that if you do not have even a few amino acids on an import on a membrane protein which imports iron, for example, then the cell cannot import iron, and you know that iron is absolutely essential for life to start, and you have no life. So my claim is that is much a bigger problem than commonly acknowledged.
Okay, but so the initial consideration is, would iron be an absolutely essential? Like, would iron be the most essential component for cells to use? Right?
Do you know an organism which doesn't use iron sulfur cores in proteins? A protein set which doesn't have proteins which use iron sulfur core. Do you know a life form which doesn't?
There are some. Most of life does. I'm not sure if all of it does.
So you know an example of a life form which doesn't use iron metal?
I'm not sure if all of them do. I know that the majority of them do. I can grant it to you for sake of argument.
Well, I don't know of any life form which doesn't use iron sulfur cores in some of
Sure,
their
I'm willing to grant that it's potentially possible for that. But the point is, what's the point?
So yeah, the point is following: if you have a cell which uses proteins, which uses in its reaction center iron sulfur clusters, so you have to make them. Okay,
well, sure.
And not true.
Well, sure. Iron and sulfur.
Okay,
Iron and other.
Just a moment, please. So I'm sorry. Okay, sorry. So, okay, since you are a biochemist, immutable, you know that in order to make an iron sulfur cluster, you need scaffold proteins, and it is a multi-step synthesis process. It is a very complex process. Is that correct?
Are you referring to like helical domains of iron sulfur cores, or are you referring to like the binding between iron and sulfur itself?
No, I'm talking about the cluster, which is used in some proteins as the core for the reaction to be able to occur.
Well, sure. I mean, to my knowledge, iron sulfur cores are naturally occurring, but the process that contains them, like the peripherin rings or whatever molecular structure that occurs that protects them or keeps them stabilized, is a different thing.
Well, the thing is that these cores, they have a very specific geometrical structure in order to be able to catalyze the reactions that they do. They are not just a bunch of atoms somehow scrambled together. They have very precise geometrical structures.
Well, yes, they're inorganic structures at their core. Those are things you would find. Those are things you would find on the Earth. These are things you would find early in Earth environment.
Well, no, I don't know. You don't simply import any kind of composition of iron sulfur, and in order to import sulfur iron, for example, do you know what is required?
To import iron?
Yes.
To import iron typically requires the activity of peripherin rings.
Well,
usually it requires the ability of heme containing.
There are some specialized molecular machines on the surface of the cell membrane, which are responsible for importing, actually to chalize and turn the iron into siderophores, which is soluble iron, which then is able the cell is then able to import it. Do you know what kind of machines that I'm talking about?
Yeah, you're talking about globin proteins.
No, I'm talking about non-ribosomal peptide synthetase machines.
Okay, we might be talking about something different then. I thought you were referring to
Okay, these
globin
are
proteins.
essential. If you have just iron at the surrounding of the cell, it isn't able to import the iron. So these non-ribosomal peptide synthetase enzymes, they work in a literal manufacturing, like a nanofactory, transforming iron into siderophores, which is a soluble form of iron, which then is ready to be imported to the cell. So if you don't have
okay, so the crucial assumption, right, and this was something that Speed was mentioning earlier when he was talking about isopropyl alcohol and something like methanol, for instance. The reason I suspect iron, and I'm pretty sure I would be correct in saying this, the reason that iron doesn't get imported readily into cells is because iron on its own, in its native state, is a 3+ cation, and that's far too charged for it to be imported into a cell. There's not enough energy for it to be passively diffused.
Yes.
Okay, that's fine. Modern cells do it by means of active diffusion. However, the thing worth consideration, and one of the purposes, like of bringing up the iron sulfur cores, as you mentioned, is that when coordination complexes form, like between iron and other compounds like sulfur and oxygen, which are fairly related compounds actually, it tends to reduce the effective charge of that iron. It tends to make it more neutral in terms of its charge characteristic. And so the purpose of bringing that up is iron on its own wouldn't be absorbed by cells. That's correct. But why would you expect it to be, right? That was the purpose of me saying.
I'm not saying that. My point, immutable, is that in order for life to start, you need, for example, these iron sulfur clusters in a part of the proteins in the proteome set for the first cell. So in order to have the manufacturing of these proteins, there is already an enormously complex structure required only to change the iron into soluble form, into siderophores. Then you need the proteins which can sense the iron in that form and import the iron into the cell. Then you need the scaffold proteins and chaperones to build that cluster. Then you need to know exactly where in the pocket of the protein it has to be inserted in the right way. It isn't just any kind of way. And all this technology is like
So the problem you're referring to about like minerals and their composition, number one, due to the Le Chatelier's principle, minerals will achieve equilibrium with their environment just because of the fact that it's more favorable for some minerals to be absorbed into a cell than to just be concentrated in the entirety of the ocean. And there will be some equilibria between.
Sorry, I don't see that as true, immutable. There was no urge for iron to travel or to.
You're aware of how diffusion works, right?
You know.
So, do you acknowledge like that passive diffusion, like why passive diffusion occurs?
I know that it occurs. Yes.
Do you know why it occurs?
Well, probably because of energy gradients or so.
Do you know what drives those energy gradients?
Excuse me?
Do you know what drives those energy gradients?
Well, the difference between the energy inside of a cell and the outside, and the gradient, the energy gradient.
Yes, precisely. So, for instance, when you have something like sodium or chlorine that's being passed into a channel, you don't always need proteins to allow that function to occur.
But you need the channel. the channel has to be. I mean, the cell uses about 30% of the genome to synthesize surface proteins on the membrane, and many are import proteins which are just there to maintain the homeostasis of the cell and to
yes. Some of those are to stabilize the internal structure of the lipid. Some of those are cell receptors that act in conjunction to tell a cell, for instance, to stop producing a certain mineral or to start producing a certain mineral. And some of those have a function of extracellular signaling, so signaling that
how do you get
within
that?
apoptosis.
So how do you get that?
Hey, hold. Okay, you're running all over the place again, Otangelo. Like you're running between this abiogenesis, and then you're going to a completely extant modern.
This is all. No. This is all.
You aren't doing that. Come on.
No.
You are doing
this
that.
is all an abiogenesis issue here.
No, it really isn't.
No, you aren't talking about abiogenesis. You're talking about cell membranes and signaling in cells.
Would you claim that life can exist without the cell membrane?
I'm saying that cell membranes on their own, right? And
you can't talk about cell membranes and abiogenesis at the same time. What are you talking about?
Like what I'm saying is when you look into cell membranes, and particularly models that try to explain abiogenesis using things like lipid world and as a model, for instance, what you discover is that they are quite accommodatable to uptake nutrients. They're quite accommodatable into accommodating lipid diversity, and they are also quite competent in terms of their ability to compete with other lipids.
First, you need to have a cell membrane forming on the prebiotic earth, and I can demonstrate you a long list of problems, and that has not been demonstrated how it can occur outside of the synthesis by cells.
You are aware that lipids on their own, that the notion of like the spherical cluster the lipids form is natural, correct?
Okay.
And you do recognize like how and why their structure occurs. That's the way they do, right?
Yeah, I know that there are some models where they claim that they form naturally, but if you do not have a system of import and export of goods, I mean, what came first? The membrane proteins which are promoting homeostasis and import and export of goods, or the membrane? Because you need both in order to have a functional.
So to me, that's a really improper question, right? The reason for that is you have a multitude of different systems that are occurring simultaneously on early Earth. So you have systems where proteins are being synthesized and degraded. You have systems where sugars are being synthesized and degraded. You have systems where mineral surfaces are allowing the production of certain molecules. You have systems that are allowing the formation of.
I mean, we are moving completely to a different topic here.
No, my point is that you have multiple systems that are occurring simultaneously.
We can discuss each of those assertions which you made, but for example, the obtaining carbon on early life is a very big problem, and the metabolism first proposal doesn't withstand scrutiny. And that has not been just claimed by me or creationists, but by a very respected scientist like Shapiro, for example, which outlined why these metal cycles, which they suppose were catalyzing the reactions on prebiotic earth, and then somehow fixed carbon. And these are all hypotheses which do not be confirmed experimentally. And the transition actually from that kind of fixing carbon to what modern cells do, even the simplest cycles, is a huge trajectory, because these cycles, they require complex enzymes.
Right. Although the question would then be, okay, is there methane? So for instance, one of the simplest form of carbon that exists is methane. And the question is, okay, is it possible for methane to be fixated within the context of geochemical cycles? Because that's ultimately the question you're asking, right?
Yeah, I
The
mean,
question you're saying is that methanogenic organisms exist which can fixate carbon into doing something else, might incorporate an oxygen here, there, or nitrogen somewhere else,
but
which is
they
fine.
all use complex enzymatic reactions and enzyme cycles.
Okay, but so the question is that the only way it can be fixated? Right.
That's a big question. That's a big question which you ask now, and science has not demonstrated how prebiotically by non-enzymatic reactions this could plausibly occur.
Well, okay, and that's one of the questions of research, right?
That's one of the big
other-
unsolved abiogenesis problems, and I can list you many of those. And they just come to a point where they say, well, we don't know, but they don't say we don't know because they have not investigated. They say we don't know because they have investigated all kinds of possibilities and have not been able to find a plausible scenario where this could be possible.
Okay, and so the thing is, the other thing to consider, number one, is to consider the question: are all forms of carbon equal? Being the question of, are all forms of carbon the same in terms of their reactivity? The short answer to that is no. Some forms of carbon, like carboxylates, will undergo certain reactions that are much easier to occur in some condition as opposed to another condition. But the point of this is saying that, okay, it could be that some carbon source, like methane, would be something that's not very easy for to fixate if it in geochemical cycles, if there's even geochemical cycles that can do that. But what we do know, and we know this quite well, is that meteorites do bring different forms of carbon to the Earth. Particularly chondrites. They bring sugars, they bring amino acids, they bring a variety of different types of carbon.
So are you a proponent of panspermia? So are you a proponent of panspermia?
Well, I think there's plenty of evidence to suggest that both astronomically and what we've discovered in terms of geology, yes, that it's very likely and almost certain that during the early formation of the Earth, it was bombarded quite heavily by meteorites.
Okay. So how does that bring you to the supply of the basic building blocks like amino acids or carbohydrates or lipids?
Funny you should mention that. Funny you should mention that, because certain amino acids are present in meteorites. They form complexes.
They are all left-handed?
Yes.
Yes?
Some of them are diastereotopic. Some of them are
100% left-handed?
Some of them are highly predominant in the forms of their left-handedness.
No. It's not about predominant. You know that life only uses 100% left-handed amino acids.
Okay, let's follow a simple argument, right? If there is a so if I have 99% of a left amino acid and a 1% amino acid within a sample, say a meteorite, then chances are what's going to be incorporated into the cellular structure or to some protocellular structure is going to be that amino acid, because it's more available to the system that's trying to.
Why would there be an incorporation at all immutable?
Because chemicals are trying to stabilize themselves, plus chemicals are going through reactions.
Chemicals, they have no aim of anything. They are just laying around on a prebiotic earth. They do not have the urge to complexify or to be sorted out into molecules which in the future eventually are used in life.
Yes, but this is the process they undergo. The process chemicals undergo is a process of complexification.
Why would there be a sorting out of molecules where the ones which are not used in life are put aside, and only the ones which are used in life would be concentrated to one place in order to have all the materials to start to complexify to become alive?
That's not the way I would frame it. The way I would frame it is that you're right in saying that molecules don't have a desire to move towards life. However, what's important is that if there are systems that are
big biogenesis problem. There is no selection process to select the molecules which are used in life. No. So what you have is
hold on. Let's consider that statement, right?
Okay.
So the tacit assumption is that the molecules that are used in life are unique. Well, to some extent, that's true. However, in the context of the context of an early Earth, right? What's going to determine there's two critical factors which are going to determine what gets incorporated into life, and that's going to be number one, which things are most available in their environments, and number two, which things are most stable in their environment. Right? So you could have millions of molecular species present, but they are not very stable at all. So they have a half-life of a day or so. Well,
yes,
okay,
that's
fantastic. But that's fantastic. They might be the most stable in terms of cells to use for whatever reason. However, if they're not stable in their environment, they're going to degrade. But the chemicals that are not susceptible to chemical reactions in the environment they find themselves in are going to be present in evolving systems. So systems like lipid systems or things like that. So one of the things you can assume is exactly that. You can assume that the molecules that life chose on, so to speak, reflects the chemical stability of those in the context of the early Earth.
Go ahead.
Well, I'm just wondering if you disagree with that, right? The premise that
is distracting.
Is my writing distracting you?
No, it's not.
Good.
I'm sorry, my daughter was distracting me here. Go ahead.
No, that's fine. What I was asking is that, do you agree that compounds that are most stable in their environment are going to be ones that are selected for?
There was no selection at that point.
Okay, why not? Because if you have molecules...
As I told you, because molecules do not have the urge or need to complexify and to become alive. They are just laying around.
But here's the thing. But here's the thing. Molecules do have an urge to become more stable based upon whatever environment they're in. So there are some chemical structures which, based upon organic chemistry, are unstable. And if given the opportunity, they will react in order to form a more stable product. Well, that puts up a selection criteria. So if you have molecules in some environment and there's tons of things going on, if you have molecules that are prone to chemical reactions, right, then those molecules are going to undergo the reactions that are energetically available to them, and they're going to transform and potentially degrade. Molecules that aren't and that are stable, such as glycine, or molecules that are simpler, aren't going to react, and they're going to be in higher abundance over time.
Oops.
Okay, did you read the paper from Steve Banner from 2012, The Paradoxes of Life?
I believe I did. It's probably been a while, though.
Okay. Do you know the problem of the asphalt paradox?
I've heard of it before, but why don't you bring it up?
Yeah, these the basic molecule building blocks of life, they, rather than to complexify and start self-replication and polymerization, they would simply degrade. And that is something which has been demonstrated in empirical experiments.
Okay, so do these beds ever degrade? Do these phosphate beds ever...
Never shown that complexification would be the trajectory that these molecules would go. The trajectory is from more complex to simpler, to degradation, to becoming asphalts. That is what is observed.
Okay, so it might mean then that the type of process that's occurring may be able to avoid their formation.
Well, you see, you are getting into speculative territory and actually not following the evidence. The
That's what
evidence,
science is.
well, no, science goes with where the evidence goes. And if the evidence demonstrates that the trajectory of molecules is to degrade and becoming asphalts and not complexifying, so why would you assert the opposite of the evidence?
Well, for one, if we observe science, if we observe biochemistry, the only thing we really can conclude is that there must be a chemical explanation of life.
Could it be also design?
If it's designed, it's very poorly designed.
Well, that's not what I asked. I asked if there is a possibility
The thing
that
is,
it would be designed. Is that an option?
it could be designed, sure, although I have no reason.
Good, good, good.
However,
That is a very important point and admission. So we have basically two options here. One is chemical reactions, prebiotically coming up with complexification and in the end self-replicating cells. And the other option would be that an intelligent agency actually injected all what is necessary to make life possible. So we have actually these two possibilities. Is that correct, Immutable?
sure.
Okay, great. So my question now following is, what would convince you, what would you need to see, what kinds of intelligent signature would you require to see to say, well, if I am observing this, if I'm seeing that kind of evidence, then this leads me rather to believe that intelligent design is a better explanation rather than unguided random chemical occurrences.
Okay, let me
Well,
let me answer that. What I would need to see is a designer capable of manipulating molecules at an atomic level.
So
And
this is the problem, Mike. This is the
like
problem,
James
Mike.
Stewart, maybe.
You asked me a very pertinent question yesterday, which I very much appreciated and liked, and I did send you about 4 or 5 different articles which I wrote or collected at my library, which is
Do any of them do any of those articles have a designer designing molecules?
Let me finish and you will understand what I am saying now. So one very important thing, Mike, is in order to come to good conclusions in regards of origins, is first to have a consistent epistemological framework. And as soon as an atheist or an unbeliever comes up with requiring a demonstration that either God exists or that he created life, then he demonstrates that he hasn't yet formed a solid epistemological framework. What you are requiring, we will never, we will never see that happen, Mike. That is not how you investigate. What you need to do is to check what is, and from there, how does it lead either to design in the past or to random chemical reactions as a better explanation, requiring that you will see a miracle happen in front of your eyes and life emerging from non-life in front of your eyes in order for you to believe, you will never presentiate that. That doesn't happen.
Why can't miracles happen now if they happened before?
Well, because God, in His grand scheme,
How do you know what His grand scheme is?
well, because we see a grand scheme developing from the start of the universe, of the fine-tuning of the setup of the physical laws based on mathematical principles. We see that the Earth has the right proportion and distances and has a moon with the right size and so forth, which is all required to have life. And we are informed in the Bible, in Genesis, that God created life some time back ago, and then permitted that it self-replicates and adapts to the environment, and not that he constantly creates again life of some sort during the history of life. So that's not what we observe, and that's not what we are having a direct revelation in the Bible that God's intent is this. So,
okay, no, none of that is evidence. None of that is in scientific papers. None of that. So,
no, I'm not
so
saying
why are
that.
you calling this science? Why are you calling this science?
The only point which I'm making here, Mike, is that if you are asking the wrong questions, you will never come to meaningful and probably truth.
Oh, I agree.
Conclusions. So if you ask me that I demonstrate you God, and if I don't demonstrate, then you conclude, and well, most probably God doesn't exist.
Well, aren't you doing exactly? Hang on, Otangelo. You're asking us to demonstrate abiogenesis in the lab. Otherwise, you are not going to believe us. Aren't you doing exactly? Hang on, you're doing exactly the same thing. Don't you see that?
No, Mike, that is just, we have two lines of reasoning. We have evidence of absence and evidence of what intelligence can do, which non-intelligence can't do. And these are two lines of reasoning which converge to the same conclusion. And
do we have any evidence of any intelligence creating a cell? Do we have scientific evidence of intelligence creating a cell? Have any abiogenesis been able to do it yet?
Well, we have evidence that natural unguided events are too unlikely to be able to come up with the kind of organized, integrated complexity and the complex instructional information which directs the making of structures. And we know only, and that is precisely what I addressed in my video, which you probably saw. And there I explain, I think, in a very detailed manner, why we have evidence that engineers, they make blueprints, and upon the precise instructions of these blueprints, they make machines and factories. But we have no evidence that unguided random events can produce blueprints equally to the genome and informational languages and ciphers and codes, and upon those making complex machines and factories. Chance has never been demonstrated to be able to do that. We know only of intelligence being to do that. And what I summarized now is basically the core of the intelligent design hypothesis.
Well, except for number one, intelligent design makes no predictions that it can be tested. And the other issue is that that argument falls apart because we can identify what intelligence that we do know already.
Well, immutable. Why is that issue of making predictions so relevant if we already know by experience that intelligence can do all these things? So we don't have to predict.
No, you don't have any evidence of intelligence making a cell. You've already said that. In fact, that is your criticism of us, that we can't make a cell. Therefore, what?
Michael,
What are you claiming?
I addressed precisely that as well in my video. And I said that when you have something which you know what made it, like we know that intelligence makes blueprints, machines, and factories. And
yes, we do know that intelligence makes cars. We don't know that intelligence makes cells.
Okay,
we've never seen it.
Maybe you get to what I want to say. Now, if you have a phenomenon of which you do not know its origin, but the phenomenon is very similar or analogously to the phenomenon of which we know the origin, then it is very unlikely to claim that that analogous phenomenon has a different source or origin of mechanism upon which it emerged. And that is precisely the point. We have analogously to what we see intelligence can do, we have what we see in the molecular world, where we see the genome, which is an information storage device. We have the genetic code, which is a translation device, which assigns meaning from the nucleotides to amino acids. We have molecular machines. We have the cell which is a factory which makes chemical compounds. So this is analogously to what we see intelligence in human life doing. So why should
Not
we
at all.
attribute that kind of thing to a different cause and source rather than intelligence? And special if science has demonstrated that the random occurrences are unable to make even the basic building blocks of life, not to talk about the complexity of molecular machines and entire cell factories.
Okay, guys. I don't want to make this too long, so what?
No, I mean this is fine for me. I mean it's amazing how you guys ignore always how the meaning and how the information is actually conveyed. And it isn't by means of how intelligent agents do
I
anything.
addressed that in my video. I mean, honest scientists like Eugene Koonin, they admit openly, we do not know by any means how the genetic code could have emerged prebiotically. They do not know how it could have been optimized in 1 million alternatives, it being one of the most robust ones.
That's
They
perfectly
do not know.
fine. And that's probably, and here's the thing, that's probably because the nature of the genetic code, the syntax, like in semantics of how the genetic code operates, based on what we observe in cells, is based on an arbitrary set of chemicals.
Yes, you said something very important now, arbitrary. Who sets the arbitrary thing? How is that conveyed that it is arbitrary? How is the assignment made from the codons to amino acids? Why should that be so by natural means? It shouldn't be so by natural means at all. We only know intelligence being able to assign meaning to codes and to signs.
Yet that's
We do
clearly
not
not
know of
yet that's
mechanisms being
clearly
able
not
to
true,
make
is it?
assignment at all.
Okay, yet that's clearly not the case.
Oh,
Because
yes, it is.
no,
It
because
is.
when we observe, hold on, when we observe Otangelo, in every step of step of the cell cycle, in terms of replication, in terms of protein synthesis and things like that, never once have we seen an intelligent agent be required for the intervention or for the cell to finish that process in an efficient fashion.
That's not what I'm
Never
talking
once.
about. I am talking about the setup, the initial setup of assignment of the codons of the meaning of the triplets to amino acids. There is no reason why chemical reactions ever should come up with assigning something to something else.
Well,
I can,
why wouldn't it be
can
based upon the
let's give you an example. Okay, I like to make analogies because they make things very clear. If you see a translation book from English to Chinese, and
Mhm.
you don't know the author of that book, and someone comes to you and asks you, immutable, there is this book where the for example the chair is translated to Jizi in Chinese, and you have
Mhm.
given the Chinese letters, and someone asks you, what do you think? Was that assignment? Did it occur randomly, or was there someone that knows the language of English and knows the language of Chinese and knows how to make the translation from one language to the other? What is the reasonable answer to that question?
More than likely a person.
Okay, great. And that's exactly the simultaneously and analogously what we see in the assignment of the codons to amino acids. There is an assignment, a pattern, and that
Yes.
pattern is analogously to a translation book from English to Chinese. How do you explain that? That's the key
Again,
question. And
uh,
Kunin has confessed we do not have an understanding how the genetic code could have emerged
okay.
naturally.
And in the models that are seeking to explain this, right? The models that people like Demeter and other origin of life researchers are putting out try to explain this in a variety of different ways. They try to
Yes,
explain it, number one, based upon the,
but they have no evidence that it can be possible because assignment of meaning only comes from intelligence, and that is very obvious.
that's
Once
not
you
quite
remove the blinkers of materialism,
No, that's
then
not
you
quite the
realize
case.
that, and then the whole abiogenesis construct simply scrambles.
That's not quite the case, though, right? Because even if I put a system which has no sense of consciousness, for instance, if I put a culture of bacteria onto a medium, and I introduce and it's overcrowded in the case that there's a very large population which is able to very easily compete for the food source, but after a certain point in time, what you expect is that, okay, well, if I have another population try to be introduced, it's got to do something. It can't compete with the other population very easily because that population.
You're moving goalposts. You're moving goalposts. What you're talking about now has nothing to do with what we were talking about.
No, I'm not. I'm trying to explain that biological systems and natural systems, what they do is they adapt to their environments based upon various environmental factors. And one of those can be the amount of food present in the environment, whatever kind of metabolic source they're using. It is perfectly rational to say that, or it is at least potentially viable to say that, look, if there's an assignment between codon and amino acid, that might well be because those two things have a very strong interaction chemically with each other for whatever reason, or, and potentially maybe even both, that this codon and this amino acid were both present in very high amounts on the early Earth, and that they stabilize each other via interaction.
Okay, sorry, I had to interrupt quick because my dog and my daughter were distracting me. So I didn't hear your last sentence, sorry.
Yeah, what I was saying is that I don't see any issue with proposing a model that says that the relationship between an amino acid and its codon triplet can be based upon either the fact that can be based on either one of two things. And the first one being that the abundance of each or the interactions that they have in each other in terms of stabilization.
That has nothing to do with stabilization because, as John Maddox pointed out very clearly in his debate with the godless engineer, there is no physical direct interaction between the triplet anticodon and the amino acid place where it is charged on the tRNA. There is a physical distance, so you cannot explain it by physical activity.
So the thing is, right? Even if that's true in modern systems, the explanation doesn't necessarily need to preclude that as an explanation.
What I really don't understand Immutable is this. We have evidence that only intelligence can assign meaning to things and make a translation book, like from English to Chinese. This is very obvious.
And the fun thing about that,
molecules, they do not have the urge or even the capacity to assign meaning. This is just something that exclusively intelligence can do.
Okay, but here's the other fun thing about that, right? Is that with the case of an intelligent designer, I can always identify who that intelligent designer is. I can always, if I want to find out the identity of a car, there's tons of ways I can go about that. I can find out the make and model of my car. I can find out the factory it was produced. I can find out who the person was.
You guys do not understand. I put that out very clearly in my video, and I will put it out again a second time here. And if you pay actually really attention, you will understand that I have a point. If you have two phenomena which are very analogously one to the other, and you know the origin of one phenomena, the making of blueprints and machines and factories and cars and so forth requires intelligence. And you see a very similar scheme, which is genomes directing the making and operation of machines and factories on a molecular level, on a far, far more complex level than humans have ever devised. Then you have an analogous procedure of constructing things for specific purposes to what man and intelligence does. So we have good reasons to infer that these things that we see on a molecular scale were also intelligently designed by an invisible creator. And there is no reason why science has demonstrated that it is not possible.
I genuinely don't see that, because what I see when I see DNA is I see that there are chemical interactions which have clearly definable relationships between each other, and that ultimately serve a final function in terms of the cell's fidelity.
I addressed this too in my video, and I said there is no reason why the genome should bear complex specified information and a sequence which produces functional proteins which also have specific purposes and which interact together like in a car. Each part interacts with the other part in a synchronized manner in order to have a functional whole. And that is what we see in cells as well.
Although
the protein is complementary to other proteins. Each one has a specific function, and this is all instructed how to make these proteins and their functions through the genome. And you telling me that all this kind of complexity and that scheme of information prescribed or instructional information dictating the making and operation of molecular machines and factories, that this could occur by random occurrences. This is simply not rational.
It's rational when you understand the chemistry. You claimed earlier you haven't. Otangelo, did you not claim earlier that you? Hold on. Did you not claim earlier that you didn't have a sufficient level of understanding of biochemistry and chemistry earlier?
What does that have to do with now?
You've said that you've read a little bit of cell biology, which is fine. But
well, I've read a lot. But what does that at all have to do? What we are here in the details.
Yes, and here's the thing.
Let's talk about the
thing, right? We can analogize.
My knowledge and understanding is irrelevant. We are here in the details, and I am making relevant questions.
Yeah, and I'm trying to answer it. And the long and short of that is that every process we observe chemically, from the Krebs cycle to nucleotide formation to anything else in cell biology, always is a material process.
Yeah, it is a material process, but the question is, how was that material process directed in the first place? Nobody knows how nucleotides were synthesized prebiotically. That's the first one. No, we don't. There is no evidence whatsoever. There is no evidence whatsoever.
That's a blatantly false claim.
Biotically. There is no evidence for this. Show me a paper
blatantly false. That's blatantly false. I have several papers I could link to you that give prebiotically possible pathways.
I can cite you the relevant investigations, and there is no evidence whatsoever how nucleotides could have formed prebiotically on the early Earth. None. Zero.
Really?
Not the base, not the ribose, not the bonds which stick them together, none the polymerizations, how the bases, the 4 bases were selected, how the atomic structure.
Hold on. You're moving the goalpost way far back, because what we were just talking about is nucleotide formation itself. The selection process, you said that there's no evidence for nucleotide formation in prebiotically plausible environments.
Correct.
Okay, that's a blatantly false claim. There is plenty of research that demonstrates how nucleotides could have formed in a variety of different chemical environments. The second part of your claim, hold on. The second part of your claim is to then conflate that to the information that nucleotides have in the context of biological systems.
Okay, now show me a paper which has demonstrated the prebiotic synthesis of nucleotides and the selection of the bases. And
those
also
are
the selection of, and
Otangelo,
also the selection of,
those are different topics.
No, we are talking about the origin of nucleotides. That's what I'm asking about.
You're asking, when you ask about how do nucleotides form, that is a question of chemistry. When you are asking something like, how are those nucleotides selected? that is a process that exceeds chemistry. That is a process that borders on biology. These are different questions fundamentally.
No, I disagree.
Yeah,
You
they
need
are.
in life. You know that immutable life uses four, or in DNA there's one more, five bases. Okay,
Yes.
the four bases. Okay, these have to be selected. There are millions of possible structures and isomers of the bases. You have pyrimidines and purines. They are not just simply there. They have to be synthesized in the cell, and they have a very specific arrangement which permits the Watson-Crick base pairing. And
Yes, they
the
do.
carbon and the nitrogen has to be in the right order, in the right composition, in order to have functional nucleotides which can be base paired. And that is by no means explained how that could have occurred. And it is interesting. There are science papers which say there are millions of possible compositions of that arrangement, of that isomerization. And why is the best possible structure there upon millions that could be selected? And again, there was no selection process around to say, okay, nitrogen and carbon in pyrimidines, that number here and that number there works best, so let's select it. That was simply not the case. And why at all would biochemistry select bases in order to be a Watson-Crick base pairing and an informational molecular hard disk device? Why?
So I can answer that question, and the first thing I'll do is I will put the name of a paper that goes into that has a study regarding nitrogen heterocycles, so the formation of purines and pyrimidines in very, very simple prebiotic mixtures, and
How were
the
the right structure selected, and you need it
so
in millions, and then
how
united with the
how the
right
right
place.
structures so how the right structure, so to speak, which I don't even think is a meaningful distinction, is based on the chemical reactivity of those nucleotides. So if you take the time to study organic chemistry, and organic chemistry is by no means a simple field, what organic chemistry tells you, and the long and short of it, is that not all chemical species are created equally. Some chemical species are very prone to react in very specific environments.
So
And
is there a urge to have a specific two-ring structure of purines and the one-ring structure of pyrimidines with the composition of 5 carbons and 4 nitrogens in purines and 4 carbons and 2 nitrogens in pyrimidines? Is there an affinity that dictates through chemical reactions that that composition should form naturally?
not sure about that particular ratio, but
There is no chemical affinity at all. You could put any atom in that composition. You could put sulfur or molybdenum or whatever you want. And in special, you need millions of them at the same building site together in order to.
No, you really don't. So the name of the article I put forth goes into essentially what it goes into. It takes about 4 to 5 very simple molecular species, reacts them, and has them react, and under a variety of different conditions, and it spits out a ton of nitrogenous bases.
Well,
And
first of all, you don't even have nitrogen on the prebiotic earth immutable. How do you
yeah,
get
you do.
ammonia? How do you get ammonia prebiotically?
You have nitrogen gas.
Yeah,
And
nitrogen gas. How do you
the
fix it?
contention,
How do you fix?
so the contention of nitrogen gas, I'm not even sure if it needs to be. That's still an active area of debate. Although I think my point's been made here. In that,
Nitrogenase, which that's such a huge problem that they even claim in Science magazine in 2016, they claimed that nitrogenase enzymes were making the composition of the less universal common ancestor. That's the size of the problem. You don't even have ammonia readily available to make the nucleobases on early Earth, and carbon is the same problem.
Okay, and so I don't see how that's an issue, because again, those molecules could be present.
That question. There is,
Okay.
as in case of many other issues, the last answer, immutable, will be, well, we are working on it. We don't know yet, but in
Yeah.
the future, science will find out, and it will be a natural explanation. Well, that's a materialism of the gaps argument. And
No, it
science
isn't.
for 70 years, they
No,
have
it
no,
isn't.
rather than coming closer to close the gap, provide
It really
answers
isn't.
to materialism, the gaps is becoming bigger and bigger, and the problem is always bigger than before. So that
The
moves you
thing is,
away from materialism rather
you,
than closer to
you,
solve the problem.
the thing is, you might have a point if religion actually solved something. If religion
Absolutely.
itself,
No, not
yeah,
religion. I posit an intelligent agency. That's all. We are not talking about religion here, immutable. I say that intelligence has the capacity to have foreknowledge and foresight to make a composition, knowing
sure.
that
And the
specific
thing is,
purines,
well,
they will be able to form the right distance from each other of 25 angstroms, and the right forces, the hydrogen forces the bonds in order to have Watson-Crick base pairing. Intelligence knows how to make blueprints which are functional and instructional, and can specify how to make molecular machines. Intelligence can do all these things, and we are talking about here about much
yeah,
higher intelligence
and
that would be required to come up with all these things rather than us. We don't come even close to make what we see in molecular biology, and we are very intelligent. So you think that no intelligence at all came up with that technology that we, with all the intelligence that we have, are not able to make? How
I'd
is
be more
that?
willing. I I would be more willing to grant this type of idea. Again, number one, if the ID proponents that are actually scientifically literate did put forth specific predictions, did put forth
I
actual,
told, I told you predictions are not necessary for the simple
yeah,
fact that we know that intelligence can make blueprints, machines, factories, turbines, energy making plants, and computers, and
and
transistors.
okay,
And
and
all
again,
this is what we see in molecular biology. And we know
right,
that intelligence
okay,
is
and again,
capable of doing this. But non
wi-
intelligence has never been observed to make any of these things.
okay, and again, when we observe something like an axe or a car or anything that is complex, how do we recognize it's complex? Because we observe the qualities of those things, and we observe, guess what? Those things can only be produced by an intelligent agent.
Yeah, exactly. And the same
The thing
things we
is,
see
when you,
in the molecular world. And how do you come to the conclusion that no intelligence was present to do all these things, which are far more complex than
so
what we are able to do?
and I'll drop out after this. So the reason I don't see it as plausible is that when I go through geology and when I look through astronomy or cosmology or any of these other facts, I don't observe the presence of an intelligence.
You don't need
I
to
don't
observe
see.
the presence. That's the problem. You have a faulty epistemological framework where you think that
No,
God has to demonstrate himself to you and show in front of your eyes how he actually makes all these things. No, that is not necessary. We just compare natural the capacity of natural phenomena to what intelligence can do, and weight one towards each other and see which one has a better explanatory power. And I am sorry to tell you, but science demonstrates that natural unguided means cannot explain even the occurrence or the make of the basic building blocks of life, not to talk about
you disagree.
all the higher
And
complexity. So, but
the
nonetheless, you guys insist that it must be a material cause, and I tell you
well,
why. It is
like,
not a problem of science. It is a problem of personal preference. I want that God is not involved. I want that materialism is true, and so it must be true, and that's it. And whatever evidence that we bring forward, it will be denied because materialism is a religion.
no, it isn't. Materialism is a consequence. So So the thing is, materialism is a consequence of naturalism. So the thing is, when we observe the natural world, everything we observe in it is material in nature. We don't observe anything
that is a logical fallacy. What is not the question. We all know that the real world exists. The thing is that we have two possible competing explanations. One is materialism and the other is theism. And if you want that materialism tops theism in explanatory power, then you need to provide good reasons why that unguided random events top intelligence
Otangelo,
in regard to causal
Otangelo,
capacity to make what we see in the natural world.
Otangelo, here's the thing that really becomes the pretentious aspect: is in part of my epistemological framework, I only assert and I only assume that which I have evidence to assume for. When I observe,
you have no reason to assume that the material natural world is all there is.
Sure, I do, because
No,
when I look outside, when I see it, sure. So when I look at a seed and I see it planted in the ground, and it grows up and becomes a tree, all I see there is the material, as the seed and the dirt and the water and the sunlight and the sunshine that fosters it into.
What puts the information into the seed to make
That's
photosynthesis?
irrelevant.
That's relevant. That's the relevant question.
Irrelevant. The process
That's
of a
the relevant
seed.
question.
That's irrelevant.
Question.
That's irrelevant to the process of a seed maturing into a plant.
No, that's not what I am saying. What you are asking now is not what is relevant to be asked. Of course, we know that when you have a seed, it has all its programming already in the genome to develop to become a grown-up tree. Of course, the question is, how did the seed become what it is? How did it get the potential how did it get the development program to make the tree become reality? That is the relevant question. How did the gene regulatory network come to be? How did the genetic information stored in genes come to be? And when we go further back, how did first life come to be? And we have addressed several issues. How did the composition of pyrimidines and purines and the isomeric composition come to be? How did nitrogen come fixed and so carbon? And all to these questions, if you weight one towards the other, you will see that science based on materialism has nothing besides speculation.
Yeah, and the thing is, what you observe
speculation actually is not compelling speculation. It's just so stories which simply do not fit.
As a matter of fact, the thing is actually, when you look into the scientific theories and you go into the sources that they're citing, they give you a very clear reason why they're making these claims. Whereas when you look at the claims of an intelligent designer, which is entirely vacuous, you see no explanation for how the intelligent designer could have done things. You see
I don't have to have an explanation of the explanation, Mutable. Otherwise, I would have to have an explanation of the explanation of the explanation, and then we have an eternal regress, and we will not come to any explanation whatsoever. So we have just to stop at the explanation that design is a superior mechanism to bring forward what we see in the molecular world. That's all.
Nope. And the reason for that is design as being put forth by intelligent design people has explained nothing.
It has. Creationism isn't just an explanation of a specific issue. Intelligent design and creationism is a philosophical and scientific approach, actually, which explains all the physical reality, starting from the origin of the universe until to the origin of complex life forms. It is an all-encompassing explanation, which is compelling based on the fact that we do know what intelligence can do compared to what non-intelligence can do, and there is a huge gap.
Hey
What-
guys,
what I would encourage-
can we try to wrap it
Yeah.
up soon?
I'm gonna stop at the statement. What I would encourage people to do for looking into this is to consider the following, right? What the intelligent design movement and any and all arguments that have been put forth by intelligent designers follow a very basic structure. We don't know, therefore God.
No, no,
too
no. It's not
complex.
the God of the gap.
It is too complex.
Okay. Angelo, we're wrapping
It
it
is-
up.
Sorry, but that's not
That is
true.
the exact
I brought
argument that
forward-
is used.
No.
Otangelo, it is God of the gaps. You can't get
No,
around.
no,
Why don't you
no,
just
sorry.
accept
The
it?
argument-
Just admit
Okay,
it.
okay,
And
Michael.
like
I will
Otangelo
end-
said,
I will
I am
end
perfectly
my
happy.
participation because I want to have lunch, and
Okay.
I will just say
Well-
this as my end statement here.
I wasn't allowed
The
to finish.
proposition God is not a God of the gaps argument. We propose God based on what we do know, and we do know that intelligence is capable of making blueprints, languages, codes, machines, factories, build them upon the precise instructions of these blueprints, and that's precisely what we see in the molecular world, where genes instruct the make of machines and factory. This is not a claim of ignorance or gaps. This is a claim of positive evidence. And at the same time, we have evidence that natural occurrences are unable to come up with that complexity. And that has
Nope.
been demonstrated in all
Okay,
the 70 years of scientific
let him have the last word.
Okay, so now let me have lunch. If you want,
All right.
guys, we can continue this in half an hour when I'm finished. But for that moment here, I think I have made my final statement. We are almost 1 hour and 40 minutes in the live chat.
Leo Filius wants to talk to Joel, and Joel doesn't want me to have anything to do with it. So could you set that up on your channel between just the two of them?
Sure, I can do that.
Okay.
Whenever you want, just send me an email and we set it up.
Okay.
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 I'll
Good enough.
finish.
Otangelo, thank you. This may have been brutal, but we like you. Okay.
Yeah, I really enjoyed to talk to you, Immutable. It was fun for me. Okay. And I'm up anytime to continue our dialogue. I think it is relevant. And thank you, Mike, to having me again at your channel. It is an honor and a pleasure.
Okay. Thank you.
Okay. Bye-bye. See you soon.
Yes. Goodbye.
Bye.